I'll put this to my analyst workspace. Let's call it transformed MRI. And then I click transform and save. You also have the option to output the fused CT and MR image that you see in the middle, and you do that just by selecting File, Save Fused. I'm not going to do that today, but just so you know that is an option there. So with that, I can go ahead and exit the 3D voxel registration module and move on to segmenting the electrodes in the CT scan. So you can see here, this is that transformed MRI that I just output. So I'm going to select my CT workspace now, and go to the segment menu, and choose volume edit. So the volume edit module will open to show you all three orthogonal planes. In this upper right-hand corner, will eventually show us a rendering of those segmented regions, but right now, obviously, we don't have anything segmented, so it's blank. I'm going to immediately jump to the semi-automatic tab here. I'm going to start out segmenting the electrodes with just simple thresholding. So I choose the threshold option, and you'll notice that this threshold double-ended slider appears here, and I'm going to increase the maximum all the way to the top. And you can see as I was doing that, the image is converted to a binary display, and also we saw a preview of the rendering. So what we're seeing is, in the 2D images in white, we're seeing just those voxels that have an intensity value, or rather in this case a Hensel unit, within this threshold range. And then also we're just seeing those voxels rendered in that upper right-hand pane. So I'm going to increase my threshold range until I see only the electrodes and the leads. Typically, the electrodes will correspond to Hensel unit around 20,000. For this data set, I'm going to go just a little bit lower than that. Kind of right in here. And once you set your threshold range, you click Define Object. Now, I still need to separate the electrodes from the leads. To do that, I will go to the Manual tab, and I'll select the Trace tool here. Now, the Trace tool allows you to define regions on any of the 2D images, or it can also be used to define regions on the 3D rendering. And that's what I'm going to do here. I'm going to draw around the electrodes to define them as a new object. First, I need to actually click the Add Object button, and I can come over to my rendering, and you can see I can just trace around. Probably not doing that too carefully, but you see the general idea. And as soon as my trace closes, all of those voxels will be changed and become part of Object 3. If you wanted to rotate the rendering, you could just click your middle mouse button, hold it down, and then drag your cursor. And then you can continue tracing additional regions, like so, and it would become a part of your selected object. I can also come up now and I can turn off my Object 2, so that we see just the electrodes. And I can also then rename my Object 3. So once that step is complete, I want to save my object map. An object map is a special file Analyze uses to do a non-destructive segmentation. So it allows you to segment up to 256 different regions of interest without actually having to change your data in any way. And the object maps are going to allow us to eventually fuse the extracted brain from the MRI with these segmented electrodes. But now I'm going to exit this instance of volume edit. And I'm going to proceed with segmenting the brain in the transformed MRI. So this is the MRI that was co-registered into the space of the CT scan. So I select my transformed MRI in the workspace, and again, I go to Segment Volume Edit. Now, if you finally need to adjust the intensities in any of your data sets, the windowing, you can go to View Intensities, and this is the same within almost every analyzed module. And I'm just going to reduce this maximum to brighten up this image a little bit. So for the brain extraction, I'm again going to go straight to the Semi-Automatic tab, but this time I'm going to use the Object Extractor tool. This is basically the same as the Object Extractor module in Analyze, which is available underneath the same segment menu. Use it a combination of seated lesion growing and morphological-based segmentation. For those of you who attended the SysCom webinar, this is the same segmentation technique that's used to extract the brain in the SysCom module. So once the Object Extractor is selected, what I need to do is move to a target slice. And for brain extraction, we're going to go for a slice that's similar to the orbits of the eyes, where both hemispheres are spatially connected. So a seed point. So we're going to set a seed point in an area of white matter. Just going to click right up here to set that seed point. And what happens is, it's automatically grown out to any voxels that are spatially connected to that seed point voxel, which also have an intensity value within this range here. So in order to segment the brain, I need to adjust the threshold range slightly. So I'm going to reduce my minimum to right here, and I also need to reduce my maximum. Even though the red boundary looks fine on this image, if we go to the binary display, you can see that the voxels corresponding to the skull are still pretty solid white. And because of the morphological-based segmentation, what can end up happening is that the segmentation will grow out and connect to those skull voxels. So we need to reduce our maximum until those voxels in the skull start to break up a little bit. So you can see they're breaking up now. And you want to reduce that maximum just until the white matter starts to break up. So right about there should work well. And then you click Extract Object. So you can see it copied that seated region growth all the slices and then performed that series of morphological operations automatically. And it's done a reasonably good job with the brain extraction here. We can review the 2D images to see the results. And again, you also have an option to rotate the rendering using the middle mouse button. If you ever want to reset your rendering, you just right-click and choose Reset Rotation. So now we can come up here and change the name of this new object. and I'll also change the color. At this point, I am ready to load my electrodes onto the brain. So to visualize the electrodes, you will go to the View menu and choose Objects. Within the Objects menu, you'll choose Load Objects. And then you're going to choose that object map file you saved from the CT dataset with the electrodes. And click Open. And you'll get a list of the objects that are in that object map. So in this case, we'll just select the electrodes object and then choose Load Selected. And I can then click Done to close the object window. So you can see over here in my rendering, we are seeing some of those electrodes on the surface of the brain. Now, because of the cortical deformation that occurs post-surgically following the electrode placement, some of these electrodes may appear to be embedded in the cortex. So to kind of adjust for that, we are going to turn on the transparency option. And to do that, you will right-click on the rendering and then choose transparency. And as soon as you do that, you'll be able to see the electrodes that are kind of inside the surface of the brain. And you also end up getting this opacity slider bar over here on the left-hand side. So for instance, we may want to increase the opacity of the electrodes, making them a little bit more visible. A nice feature here in the volume edit modules, you can go back to the Browse option underneath the Semi-Automatic tab, and you can then click on any point in the rendering and see the corresponding location and alter those orthogonal planes. You can also do the same from the actual orthogonal images as well. At this point, you would likely want to save your object map, and that completes the electrode grid visualization process. So at this point, there are a few extra steps you could take beyond this. You could save your object map as a displayed and then take your data set and that object map into the volume render module to create more detailed renderings, or you can also generate movies. You can also choose to output the fused CT and MR images from the 3D muscle registration module, and you could push those out to a PAX, for instance. You can also